Okay, so in this lesson we're going to solve absolute value inequalities that are the form absolute value of ax plus b is greater than or equal to c, and we're only going to focus on inequality, absolute value inequalities where c is positive. This number over here will be positive. So remember, in the previous lesson, if you notice the difference, in the previous lesson we looked at absolute value inequalities that are less than or equal to c. And then now we're going to look at absolute value inequalities that are greater than or equal to c. Okay, so in the previous lesson, I want to remind you that when we did the previous lesson, real quick, when we did the previous lesson, we rewrote the absolute value. See the absolute value less than? We wrote it as a compound statement. All right. So the question becomes, if it's greater than, do I do the same thing? Do I write as a compound statement? All right. Well, let's investigate this. Let's see if we do or not. So we're going to remember in the previous lesson when we first started out, we looked at this example, this simple example, absolute value of x is less than 3, and we kind of shaded in the solutions, and then we came up with how to end up writing all of them. Well, we're going to do the same thing here. So this time we're going to say find the solutions of the absolute value of x is greater than 3. So let's do that. So the previous one, we looked at absolute value of x is less than 3, and we saw that we can write as a compound statement the solutions. And over here, let's see if that's the same thing, if it is or not. Okay? All right, so just like with the last time, we're going to put this on the number line. We're going to put this on the number line, and I'm going to ask you, I'm going to do it this way first. So I'm going to say, is 4 a solution to this inequality? All right. So is 4 a solution to this inequality? Well, what's the absolute value of 4? The absolute value of 4 is 4. Is 4 greater than 3? The answer is yes. So that's a solution. Is 5 a solution? Well, what's the absolute value of 5? Well, the absolute value of 5 is 5, and 5 is greater than 3. So that is a solution. What about any number between them? 4.5. The answer is yes. So I can shade in that. What about 6? What's the absolute value of 6? The absolute value of 6 is 6. Is 6 greater than 3? The answer is yes. In fact, I want you to think about this. Do y'all see that any number greater than 4 is a solution? 100? What's the absolute value of 100? 100, and 100 is greater than 3. So you see you have that arrow here. So that's pointing towards that idea of infinity, right? Pointing towards that idea of infinity. All right. Whereas in the previous lesson it did not. All right. What about 3? Is 3 a solution? What's the absolute value of 3? 3, and is 3 greater than 3? The answer is no. So I'm going to put an open circle here. What about 3.5? Any number between 3 and 4. 3.5, let's say. What's the absolute value of 3.5? The absolute value of 3.5 is 3.5, and 3.5 is greater than 3. So I'm going to shade that in. All right. What about 2? Is 2 a solution? What's the absolute value of 2? 2, and is 2 greater than 3? Nope. Now I'm not going to put anything there. Okay. I'm not just so you notice I put an open circle here. I'm not going to do that here because there's a reason, and you're going to see it in a little while. Is -1 a solution? No. Right? The absolute value of -1 is 1. 1 is not greater than 3. Is -2 a solution? Same reason. The absolute value of -2 is 2, and 2 is not greater than 3. Okay, I'm going to come back to -3, but let's go to -4. Is absolute value of is -4 a solution? What's the absolute value of -4? 4. And is 4 greater than 3? The answer is yes. That is a solution. What about -5? What's the absolute value of -5? 5. And is 5 greater than 3? Yes. That's a solution. What about -4.5? What's the absolute value of -4.5? -4.5. And the absolute value of -4.5 is 4.5. And is 4.5 greater than 3? The answer is yes. So I'll show you that in. What about -6? Same thing. In fact, any number less than -4 is a solution as well, and that's pointing towards that idea of negative infinity. But let's come back around here. Is negative 3.5 a solution? Negative 3.5. What's the absolute value of negative 3.5? 3.5, and 3.5 is greater than 3, so it is a solution. So all these are solutions as well. In fact, and now I'm going to ask you this: is negative 3 a solution? Just like I asked you, is 3 a solution? You saw it was not. That's why you put an open circle there, because you see this 3, that 3, and this 3, negative 3, opposite. What is the absolute value of negative 3? The absolute value of negative 3 is 3, and is 3 greater than 3? The answer is no. But if I go down to, let's say, negative 2.99, what's the absolute value of negative 2.99? I'm sorry, negative 3.001, excuse me. Negative 3.001. What's the absolute value of negative 3.001? 3.001, and that is greater than 3. So any number less than negative 3 or any number greater than 3 is a solution to this. So, remember how we wrote this in interval notation? Remember when we wrote this in interval notation? In interval notation, you said this. You said negative infinity to negative 3, right? Union, and then 3 to infinity. That's how you wrote that. But as an inequality, and this is going to be important because that's how you're going to set these things up. You're going to set the greater than absolute values this way. As an inequality, what this means in terms of the variable x means this. Okay, listen carefully. This right here means x is less than negative 3, right? This right here means that. Or, union, or, use the word or now, not and, or x is greater than 3. Okay? So x is less than negative 3, x is greater than 3. So whenever you see an absolute value greater than inequality, you're going to write it as an or statement. You're going to write it as an or statement. An or statement. As an or inequality. You can never write, never, ever, ever write an absolute value greater than as a compound inequality. You cannot. The only way, the only inequality you can write as compound inequality is if this is absolute value less than. If it's greater than, it must be written as an or statement. And so here's what I want you to recognize about how you're going to write as an or statement. Okay, you see this right here? Here's the way I would think about this. You're going to rewrite this without the absolute value bars. So if you take the absolute value bars off, you get x is greater than 3. So there's one of them. Okay? Now, to get the negative 3, you're going to reverse the symbol. You're going to reverse that symbol. So opposite and then reverse. Opposite and then reverse. So you're going to say x is greater than 3 or x is less than the opposite of 3. Okay? That's how you're going to do it. All right, so let's go to number 1. It's not difficult. It is not difficult at all. So number 1, let's say we had the absolute value of x plus 1 is greater than, let's say, 4. Okay? All right, so absolute value greater than, whenever you see absolute value greater than, think of the word or. Think of or. Okay? Absolute value greater than, think of or. So like greater, G-R-E-A-T-E-R, E-R, but instead of E-R, think O-R, the word O-R, okay? Let me write this better, G-R-E-A-T-E-R. So remember greater than, but think of this as O-R. So whenever you see greater than, think or statement. So you're going to write this as two statements with an or between them. So your first statement, I'm going to put this on this side, your first statement, you're going to rewrite this without the absolute value bars. You're going to say x plus 1 is greater than 4. The other one is where you're going to switch all of this. Switch all of this. So x plus 1 is less than, and then the opposite. And so those are your two statements. And then you solve each one individually. Okay? So it's very simple. So you're going to subtract 1 from all parts. So you get x is less than negative 5. Okay? Or your solutions will come from over here, subtract 1, you get x is greater than 3. So the solutions will be any real number that's less than negative 5 or any real number that's greater than 3. So on your graph, if they ask you to graph this, here's negative 5, here's 3. Oh, less than, greater than, no equal sign, right? So you're going to put open circle to the left. So that's this right here. And then this one, open circle to the right. Okay? Interval notation. Interval notation. So remember with the R, you're going to use that union. Okay, R, union. Okay? So for that one, you're going to say parentheses 3 to infinity. And for this one, always go from left to right. Always go from left to right. For that one, you're going to say negative infinity to negative 5, parentheses. Okay? So process is simple. Greater, think R statement. Greater, 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 greater. Think R. So R statement, separate them. Right. First thing I would put here is this without the absolute value bars. And then you're going to, on this side, you're going to just reverse everything here. You're going to, the greater than becomes less than, and then you take the opposite. Okay? All right, let's do number 2. It's very simple, not difficult at all. Very simple. So in number 2, we have the absolute value of 2x minus 1 is greater than or equal to 5. So absolute value greater, right? Greater, so you can think R. So you're going to write this as an R statement. And so your first statement will be this without the absolute value bars. So 2x minus 1 is greater than or equal to 5. And then the other statement will be this, and you're going to switch the inequality symbol and take the opposite. So it'll be 2x minus 1 is less than or equal to negative 5. So those are your two statements. And then you just solve each of those linear inequalities, and you go from there. It's fairly easy. So this is the more difficult part, is just remembering this, and then the rest is easy. You're just solving each inequality. All right, so let's go ahead and do that. So I'm going to add 1 to both sides. So here I get 2x is less than or equal to negative 5, and 1 is a negative 4. Divide both sides by 2, and then simplify. I get x is less than or equal to negative 2. So any number less than negative 2 is a solution to this absolute value inequality. And you can check it. Let's go ahead and check one of them. Let's see if that's true. So negative 3 is less than negative 2, right? So let's see if that's true. So let's check it. So is x equal to negative 3 a solution to this inequality symbol? 2x minus 1 is greater than or equal to 5. So in place of x, I substitute negative 3. So absolute value of 2 times negative 3 minus 1. And I want to see if that's greater than or equal to 5. Order of operations, multiply first. 2 times negative 3 is a negative 6. So I have the absolute value of negative 6 minus 1. Right? Negative 6 and a negative 1 is a negative 7. And what's the absolute value of negative 7? Absolute value of negative 7 is 7. And is 7 greater than or equal to 5? Is it? The answer is yes. So that's why you see negative 3 in here. So negative 3 is a solution. Any number less than or equal to negative 2 is a solution to this. But there's another part of that solution, and that's going to come from here. So you got to go further with that. So I'm going to add 1 to both sides. So I get 2x. 2x is greater than or equal to 6. Divide both sides by 2. I found the other set of solutions. The other set of solutions is any number greater than or equal to 3. Okay? So if I put this on the number line, if I graph my solutions, so you have your solutions are coming from two inequalities. X is less than or equal to negative 2, and x is greater than or equal to 3. So put this on the number line in order, negative 2, 3. Notice there's an equal sign, right? So you're going to put closed circle, and you're going to shade in everything to the left. So that graph, make sure you put an arrow. That graph is this one. Over here, closed circle to the right with an arrow, and that graph is a solution to this. These two graphs, anything that's shaded, is a solution to the original. All right? And interval notation, you're going to say negative infinity to negative 2 bracket, union, remember R, right? R, union, bracket, that's a bracket, by the way, let me go ahead and fix it. That's a bracket 3 to infinity. Okay? Now, you see this part's not shaded, right? This part's not shaded. So one of the numbers in here is, let's say, 1. So 1's in here, right? So let's see why 1 is not a solution. So I'm going to ask, is 1 a solution to this inequality? It better not be because I don't have it shaded. So is x equal 1 a solution to the absolute value of 2x minus 1 is greater than or equal to 5? So let's check. So in place of x, I'm going to substitute 1. So absolute value of 2 times 1 minus 1. And I want to see if that's going to be greater than or equal to 5. Order of operations, I multiply before I subtract. 2 times 1 is 2. So I get the absolute value of 2 minus 1. 2 minus 1 is 1. And the absolute value of 1 is 1. So is 1 greater than or equal to 5? Is 1 greater than or equal to 5? The answer is no. So that's why 1 is not a solution. That's why it's not shaded, because it's not a solution. All right? Okay, very simple. Not difficult at all. This is you can easily do this. Just remember, greater than, you write as an or statement. Number 3, we have 2 times the absolute value of x plus 5 is greater than or equal to 8. So you may recall in the previous lesson, when we looked at absolute value less than, you may recall our discussion on this. So we said that if this number on the outside, this coefficient of the absolute value expression, is negative and you distribute, what you're going to write is no longer going to be equivalent. So you got to be careful. So we talked about the fact that if you see a number on the outside other than 1, so you see a 2 here, we talked about the fact that what you want to do to be careful is to first of all isolate the absolute value expression first. So what we're going to do is I'm going to underline this part here to remind myself that that's what I want to get by itself. So we're now multiplying by 2. I'm just rewriting this over. We're now multiplying by 2. The opposite is to divide by 2. So when I divide by 2 and I reduce, these 2's divide out. 1 times the absolute value of x plus 5 is the absolute value of x plus 5 is greater than or equal to, and 8 divided by 2 is 4. And now this right here, looks like something we did already, or something similar. The absolute value greater than or equal to. Okay? So this is greater than, right? So think or, greater, or. So you can write an or statement. So you're going to rewrite this without the absolute value bars. You can say x plus 5 is greater than or equal to 4. And on the other side, you're going to say x plus 5 is, and then you just reverse all of this, is less than or equal to a negative 4. Make sure these numbers here are opposites, 4, negative 4. And the inequality symbols are reversed. Greater than or equal to, less than or equal to. Okay? All right. And now we're going to solve each linear inequality. So I'm going to subtract 5 from both sides. And I get x is less than or equal to negative 4 and negative 5 is a negative 9. Over here, subtract 5 from both sides. Combine like terms, I get x is greater than or equal to 4, subtract 5 is a negative 1. So my solutions to this original inequality will be any number, any real number, less than or equal to negative 9, or any real number greater than or equal to negative 1. If I graph this, it will look like this. Make sure you put them in order. Negative 9 first and then negative 1. Negative 9 is smaller than negative 1. Or negative 1 is greater than negative 9. Larger than negative 9. So I'll put a closed circle negative 9. We go to the left. So this is the graph of this one. The graph of this one is going to be this. Closed, going to the right. Okay? As an interval notation, you're going to say, make sure you go from left to right. Negative infinity to negative 9, parentheses, negative infinity, negative 9 with a bracket because it's closed circle or equal sign, union, bracket negative 1 to infinity. Okay? All right. Now notice, I want you to notice something. So you see that negative 2 is not a solution, right? So negative 2 is right here. That's not shaded. So I just want to, just like it did in some of the other problems, I just want to ask you this question. Let's see why negative 2 is not shaded. So it's not shaded because it's not a solution. So let's see. So is x equal negative 2 a solution to this? 2, absolute value of x plus 5 is greater or equal to 8. So we know the answer. The answer better be no. So let's see why, though. So in place of x, I'm going to substitute 2. So I get negative 2, rather. So I get 2 times negative 2 plus 5. And we'll see that's greater than or equal to 8. Order of operations within the absolute value bars, negative 2 plus 5 is 3. 2 times the absolute value of 3. The absolute value of 3 is 3, so 2 times 3, which is 6. So is 6 greater than or equal to 8? And the answer is no. So that's why x equal negative 2 is not shaded. So anything not shaded is not a solution. Anything that's shaded is a solution. All right, that was number 3. Okay, let's look at number 4. So in number 4, we have this. We have negative 3 times the absolute value of 2x minus 1 is less than or equal to negative 12. All right, now remember, don't confuse absolute value bar with parentheses. All right, and if you do, if you overgeneralize, you're going to distribute this, and what you're going to write will no longer be equivalent. Those two things you write are no longer equivalent, and so everything you do from then on is incorrect. Okay? All right. So, just like within the previous problem, you want to isolate the absolute value bars by itself. So right now, I'm multiplying by negative 3, so I want to get rid of that negative 3. Okay? So let me go ahead and rewrite this over. And, all right, so I'm going to divide both sides by negative 3. Because I'm multiplying by negative 3, the opposite is divide by both sides by negative 3. Okay, but remember, whenever you multiply or divide an inequality by a negative number, you must reverse the equality symbol. So whenever you divide or multiply both sides of an inequality by a negative number, reverse the inequality symbol. Okay? Reverse the inequality symbol. So you see I divided both sides of an inequality by a negative number, so I got to remind myself I got to reverse this. Okay, let's simplify. Negative 3 divided by negative 3 is 1. So you see 1's in the S factors. 1 times the absolute value of 2x minus 1 is the absolute value of 2x minus 1. Is greater than or equal to, I had to reverse, right? Reverse, because I divided by a negative number. I divided this inequality by a negative number. And a negative 12 divided by negative 3 is a positive 4. All right, so now we have a greater. We have a greater, absolute value by itself and greater. So that's that or statement. So you're going to rewrite this without the absolute value bars. So 2x minus 1 is greater than or equal to 4. And on this side, you're going to say 2x minus 1 is less than or equal to a negative 4. So you're just going to reverse everything you see there. Okay? All right. So remember, whenever you rewrite it, though, you're going to rewrite it without the absolute value bars. And so you must go from here to here. You must show this. Okay, that's your work. All right, now I'm going to solve each linear inequality. So I'm going to add 1 to both parts here. So I get 2x is less than or equal to negative 4 plus 1 is a negative 3. And then I'm going to divide both sides by 2. And so one of my solutions to this original inequality right here, in fact, the solutions to this, solutions to this, solutions to this are all the same. It's going to come from here. X is less than or equal to a negative 3 halves. So anything less than or equal to negative 3 halves is a solution to this inequality, is a solution to this inequality, is a solution to this inequality. Okay? Over here, when I add 1 to both sides, I got 2x is greater than or equal to 5. Divide both sides by 2. I get x is greater than or equal to 5 halves. So any number greater than or equal to 5 halves is a solution to this inequality, this inequality, this inequality. All right. So if I graph it, it'll look like this. So let's say this is negative 1, this is negative 2. So negative 3 halves is negative 1.5, so that's here. Equal signs, put a closed circle, okay? And let's see, that's what, 2.5? So let's say this is 0, 1, 2, 3. So 5 halves is 2.5. Notice the equal sign, so that'll be a closed circle as well. Okay, over here, so x is less than or equal to negative 3 halves, so it's going to go this way. So any real number shaded is a solution to any of these inequalities. In particular, remember I wanted to solve the original. Over here, any number greater than 5 halves is a solution as well. All right, notice that's a closed circle. In interval notation, your solutions, and you read a graph from left to right, your solutions will be negative infinity to negative 3 halves with a bracket, union, or union, okay, or statement, union, and then from bracket 5 halves to infinity. And remember, negative infinity and infinity, you always use parentheses, whether you have an equal sign or not. Okay, so those are the solutions. The solutions to this inequality is the same as the solution to this inequality, which we found to be these two intervals, or these two graphs, or these two inequality statements. All right, so let's do one more. So number 5. So fairly simple, right? Not difficult at all. It's not a difficult process. Very simple. So when I look at number 5, I have this. I have negative 4 is less than, negative 4 times the absolute value of 3x plus 1 is less than negative 20. All right, now be careful. Sometimes you look at this and you say less than, when you see less than, you think that previous lesson, which was a compound. But be careful. Always get the absolute value by itself first. So right now I'm multiplying by negative 4. I'm just rewriting this over. So since I'm multiplying by negative 4, I'm going to go ahead and divide by negative 4. Now do not distribute. This is not a parentheses. That's absolute value. If you distribute, that statement you write is no longer equivalent to this. Okay? You cannot distribute a negative within the absolute value bars. That's mathematically not correct. Okay. So I'm dividing by negative number, inequality by negative number. So remember, you got to reverse this. So the negative 4's divide out. You get 1's as factors. 1 times the absolute value of 3x plus 1 is the absolute value of 3x plus 1. Notice the steps. Less than becomes greater than. I have to reverse it. And then negative 20 divided by negative 4 is a positive 5. Okay? And now notice I have an absolute value greater than. So now, or statement. So your inequality you're going to put here will be this without the absolute value bars. So 3x plus 1 is greater than 5. And over here, you're going to say 3x plus 1, and you just do the opposite of what you see. Greater than becomes less than, and you're going to take the opposite of 5, which is negative 5. And now, notice you're going to go from absolute value to 2 inequalities without the absolute value symbols. Now, we're all dealing with linear here, with linear expressions. So you're going to go from this absolute value inequality that has a linear expression in here to 2 linear inequalities. So I'm going to solve these linear inequalities. So the solutions to this and the solution to this are the solutions to this, and then the solutions to this. So if I can find the solutions here, then those are going to be the solutions here. Okay? So I'm going to subtract 1 from both parts and from both sides, and so I get 3x is less than negative 6, and negative 5 and negative 1 is a negative 6. Divide both sides by 3 and reduce. I get x to be less than negative 2. So any real number less than negative 2 is a solution to this inequality. Over here, if I subtract 1 from all parts, I get 3x is greater than 4. Divide both sides by 3. The other set of solutions will be any real number greater than 4/3. Okay? On the number line, If this is 0, this is -1, this is -2. On -2, I'm going to put an open circle. There's no equal sign. Less than. So this is a graph of the solution to this inequality statement. Over here, 4/3, remember, is 4 1/3, is 1 1/3. So if this is 1 and this is 2, 1 1/3 is closer to 1. And so you're going to go to the right. So these two graphs represent the solution set. So these two graphs represent solutions to this inequality. Okay? So in interval notation, and you always read it from left to right. So you go from -infinity to -2, parentheses, union, and then from 4/3. See, this is 4/3 here. Parentheses 4/3 to infinity. So any real number within those two intervals or these two graphs will be solutions to this, this, and this. All right? So real quickly, in this interval here that I'm pointing to, 7 is in here, right? 7 is in here. You see, 7 is shaded. So that means 7 is a solution. So let's see if 7 is a solution. So I'm going to ask you this question. Is x equals 7 a solution to this absolute value inequality? -4 times the absolute value of 3x plus 1 is less than -20. So in place of x, I'm going to substitute 7. So I get -4 times times the absolute value of 3 times 7 plus 1 is, and I want to see if that's less than -20. Order of operations, I multiply before I add. 3 times 7 is 21. 21 plus 1 is 22. So I get -4 times the absolute value of 22. And I want to see if that's going to be less than -20. The absolute value of 22 is 22. So this is -4 times 22, right? And -4 times 22 is a -88. Well, is a -88 less than a -20? And the answer is yes. That is true. Okay, so that's why x equals 7 is a solution, and that's why you see it shaded here. Okay? All right, so that is, let me find the first page. So that is how you are going to solve an absolute value greater than inequality. All right, so you're going to write it as an or statement. You're going to split it apart as an or statement. All right, and so that is the end of this lesson.